Welcome to my study, and we're going to talk today about Chapter 4 from the Geary book. Chapter 4 is about cases, Geary used to call them pseudoscience examples. He quit calling them that and started calling them marginal science examples. And the reason is because it's very hard to say what the difference is between science and non-science. And unless you can say precisely what the difference is between a scientific theory and a non-scientific theory, it's not really clear what you're supposed to say when you call something pseudoscience. It's not clear that there is such a category. Maybe the difference between good science and bad science can be made relatively clear, but maybe the difference between what counts as science and what doesn't count as science can't really be made clear. So instead of using a pejorative term like pseudoscience, he now just calls it marginal science. And what he means by that is these are examples of what goes wrong when you're trying to do science. What are the pitfalls? What are the signs of something that isn't really providing very good evidence for the conclusions that are drawn from it? So we get 4 fascinating examples, 4 or 5, I can't remember which it is. We're not going to focus so much on the details of the examples as we are the lessons to be learned from them. So you will read about each of these episodes in the Geary book. And the descriptions are kind of fascinating. It's fun to see how people succumb to all sorts of quackery of one sort or another. Human beings are susceptible to this. And one of the good things about looking at episodes like this is to become wary of being sucked in by people who want to sell books or just love notoriety. So there's a kind, when you see things about reincarnation, that's one we're going to look at. Some people just get all super excited at the possibility that reincarnation actually happens. Shirley MacLaine is one of those people. They just get wide-eyed and all sorts of wonderful things are going through their blood vessels. Adrenaline rushes happen to people like this. And maybe there's something really important to be learned, but as we will find out, there are cautionary tales when you start getting all too excited about some monumental discovery. So let's take a look at the slides and look at how to think about cases of marginal science. So let's begin by reminding ourselves of the diagram we're using for describing and characterizing any particular reported episode. So we have, for contrastive confirmation, 2 models, the part of the real world that we're trying to model. Then we have predictions from each of the 2 models, and then we gather some data. And we do that to see which of the predictions agrees with the data, and then we draw conclusions about whether the model fits, whether we have confirmation that the model fits reality or doesn't fit it. In the ideal case, we want to be able to characterize these 2 different models very carefully. And then what we're wanting, we'd really like crucial experiments where the predictions of one of the models is incompatible with the predictions, are incompatible with the predictions of the other model. Then we will get fairly strong confirmation as the result of doing the test. Now, as we will see, in cases of marginal science, it's hard to get that sort of a result. So let's take a look at first the Freud example. Freud, by the way, historically is one of the targets of people who thought in the early part of the 20th century that there was too much bogus science going around. First, they thought there's too much reliance on non-science when it comes to public policy and educational policy, how to structure government and society for the well-being of, for the good of the people in the society in question. So in the 1920s, the Vienna Circle and successors to it were worried about the social reform policies being adopted in Austria after World War I, and too much of what was being done paid no attention to the best science of the day. That's a recurring theme ever since the 1920s. Even when we have good science, it's often disregarded by political leaders. So that was one of the things that concerned the Vienna Circle. As a result of their concern, they developed a conception of science and tried to characterize the difference between what was a scientific theory and what was quackery or non-science or pseudoscience or something like that. So the targets of these people are things like astrology doesn't count as a science, it's quackery of one sort or another. Marxism doesn't count as a science, it's maybe political philosophy of some sort, but it's not a scientific theory, so it was said. So they had a demarcation principle that they were endorsing, and it had to do with things like repeatability of experiments and the possibility of empirical confirmation and disconfirmation. The details can be studied in other courses. We're not going to look at that so much. The course where it's talked about the most is the History of Analytic Philosophy course that I teach, if you're interested in those details. But in any case, Freud was also a common target. Freudian psychoanalytic theory was held to be unfalsifiable, and that's a defect, they said. In fact, it was a mark that the theory in question was not a scientific theory. So it's not surprising to see Geary talking about Freudian theory here. So what do we get from Freud? Freud's got a theory. It's a theory that you're probably all pretty familiar with. The human person is a construction of id, ego, and superego. So the moral stuff is in the superego region. The id is governed by the pleasure principle and involves an unconscious realm. The ego is the level of consciousness, but also something Freud calls the preconscious, that's where memory resides and things like that. So things that you can get at, but you're not presently aware of or thinking about. So we have id, ego, and superego, and attached to it is Freud's theory about stages of human development, all of which focuses on libido issues. So you get a focus at various ages when things go well. Surprisingly, there is no focus for the libido in the latency stage from 6 to 12. I don't know what that means. Maybe when you're 6 to 12, you never think about sex or anything like that. I don't know what that means. But in any case, you get a various foci, and at each stage, various developmental achievements are hoped for, and if things don't go well, you end up fixated at a stage rather than developing properly. So that's the story that Freud developed, and it's worth noting that Freud's experience in developing this theory had to do with mental hospitals and patients in mental hospitals, which isn't exactly a representative sample of human beings, at least we hope not. So the particular example has to do with this poor little boy, Hans, and his fear. You can read details of it in the Geary textbook. But the important thing is, what are the two theories? What are the two models that we're comparing? And Freud's model is that poor Hans has an Oedipal complex. And I suppose the alternative is, let's call it the folk theory, just the theory, the common sense theory that probably your grandmother might cite to explain what's going on with poor Hans. All right, so let's call a folk theory just the sort of stuff that common sense gives you. And we look for a fit, and it turns out both of the theories are going to fit with the data that we're going to gather. So what's the calculation? What does folk theory tell us about the development of fears and their dissipation over time in children? Now, if your grandmother was anything like my grandmother, the phrase, the sentence, "it's just a stage," gets used all the time. things come and go in human beings. It's not just true of children, it's also true in adults. Things bother you for a period of time and then they go away. Things that you never think about all of a sudden become really important at some point, and they dominate your inner mental life. So folk theory just says change is what you expect in human beings. Things come and go. If you're deathly afraid of something for some period of time, yeah, you'll probably get over it if we just wait a while. Now, the Oedipal theory also predicts something that's needed to get over the fear and how it can be gotten over. So folk theory says we expect change to occur. Even if you do nothing, we expect change to occur. And the Oedipal theory predicts that such change will require a kind of self-awareness in Hans so that the hurdle can be gotten over. So then we do a test. And the test involves simply treating Hans by having him visit Freud for a while, and it turns out after 6 months or so, we notice dissipation. And of course, Freud will take credit for that dissipation because he says the sessions were aimed at developing a certain kind of awareness in Hans. That happened, and so dissipation occurred with the fear. So we get agreement between what happened and the calculation from the Oedipal complex theory that Freud was proposing here. But Grandma's folk theory seems to do about the same sort of thing. It says, oh, it'll probably go away. It's a weird kind of fear. It would be surprising for it to grip Hans forever. So we also get dissipation agreeing with the prediction of folk theory. That's a problem for Freudian theory. And the lesson is sometimes a cigar is just a cigar. Second example, astrology. Here, Geary doesn't really do a whole lot of in-depth work about particular episodes or anything like that. Instead, his example just has to do with his own personality. Now, when he discusses this, it's not really clear what the alternative model to astrology is, but he focuses on the astral force explanation of what he's like. And so, since we really don't know what the alternative model is, it's hard for us to assess what degree of fit there is. But, as we will see, it's also hard to assess what degree of fit there is between his personality and the astral force example as well. So we're supposed to do some calculations, but it's hard to do that from a model that you don't know anything about. What does the astral force model predict? Well, its predictions are extremely generic. That's the hallmark of astrological predictions. In fact, if you take a look at your horoscope, it gets boring pretty fast, but you'll see extremely vague remarks so that no matter how your day goes, it looks like you can interpret what happened to you on a given day to fit with your horoscope no matter what happens. So suppose the horoscope says, today something pretty neat is going to happen to you. Yeah, that's too generic to be the hallmark of good science. And what a sad day it would be if nothing pretty neat happens to you all day long. Probably you just weren't looking. I mean, every day something disappointing happens, something pretty neat happens. Life is full of ups and downs. Any attempt to generate a prediction from that sort of information is going to result only in generic and flawed science. So in any case, you get a prediction from the astrological model, and then you run a test, but the results of the test are also vague. I mean, really, you need some precise prediction so that you can run a precise test. In the absence of anything approximating precision, you're not going to learn anything. So you get a kind of agreement between the vague results of the experiment RG runs on himself and the generic predictions in question. And we don't know what an alternative model would look like. Now, the important thing here isn't so much the details of the discussion of Ron Geary's personality, but rather the way in which vagueness and generic predictions are the hallmark of either sloppy science or marginal science, maybe even non-science, pseudoscience are appropriate words here. But vagueness and generic character to what you're doing is just a waste of time. Good testing requires specific predictions based on precise calculations. So think about what we talked about in chapter 3, especially Lavoisier's rejection of the phlogiston theory. There's not any precise numerical predictions that are generated by Lavoisier before setting up his experimental apparatus and running his exam, but it's nonetheless a kind of specific set of predictions, because what we got was that the water level and the weight in the atmosphere were both supposed to change in measurable ways. So air was supposed to go up, and that meant water was supposed to go down under the domed chamber that he had constructed. And the result of the experiment was the exact opposite. So there we have extremely good, specific predictions, even though they're not numerically calculated. He didn't tell us how much the weight was supposed to go up or how much the water level was supposed to go down. But it was crucial that we knew if phlogiston was being released, that those are the two things that would happen. With respect to the astral force predictions about Geary's personality, we don't see anything specific enough to run an experiment. Our third example has to do with extraterrestrial visits, and this is a book, Eric von Donigen's book, Chariot of the Gods. If you want to get rich, if you can sell 7 million copies of a book, you're going to be doing pretty well. And this is an amazing claim being made. It's fascinating to think maybe extraterrestrials have visited Earth. What's interesting is not so much the speculation, but whether or not you can produce some evidence for it. And that's what von Donigen claims to be able to produce, evidence of extraterrestrials. So the book sold a lot of copies, and I don't know, maybe they're all wide-eyed, gullible people that bought copies of the book, but maybe it's worth checking out. If you don't know what the claims are, maybe you'd like to find out, is there really any evidence of extraterrestrial life? So what are the things that he's trying to explain, the parts of the world? Well, there are various myths about the gods. There are pyramids, Easter Island statues, really unusual road patterns in Peru. So he's got a whole bunch of things that he's going to talk about. So we're just going to call that varia. That's the parts of the real world that he wants to understand. What's our alternative model to his extraterrestrial visits model? That's unclear. So maybe we're back at the original Geary model, where you just have a model and reality. You've got a 4 fundamental character diagram, and then you try to draw conclusions about whether you've got any evidence for the model from what you observe. Contrastive confirmation is the more standard thing that you're looking for, but it's hard to do if you can't specify an alternative model. Now, maybe what you should say here is looking for a model isn't really the right way to think about this, because the the phenomena in question are so disparate and form no natural kind in nature that there can't be a model. I mean, why are you even thinking we need a model to give a common explanation for all of these things? And the answer is you shouldn't be expecting a common explanation for all of those things. You should expect one explanation for how myths arise and how gods end up being described. That's what religious studies investigates. What about the pyramids? How did they get built? I think we should talk to the engineers. How about the Easter Island statues? Maybe anthropologists. How about road patterns in Peru? I don't know who you talk to about that. Probably historians, civic engineers, something like that. So maybe you shouldn't be expecting a common explanation for all of these different things. And maybe that's the mistake. But the claim von Däniken is making is there is a common explanation that should be considered: extraterrestrial visitations. So what degree of fit do we have between the alternative model and the stuff in question? I guess that depends on, after you consult with the relevant disciplines, you see, can we explain myths about the gods? Can we explain pyramids? What's our understanding of these Easter Island statues, etc.? Maybe the degree of fit just depends on what you find out when you investigate each of the phenomena individually. There's going to be a question as well about whether the extraterrestrial visit model fits all of these as well. Let's see why. So you're going to do calculations based on the first model, which of course are going to be indefinite because you don't really have a unifying alternative explanation for these various things to be explained, and it's not clear you should be looking for a unified explanation. So you do calculations about extraterrestrial visits. Well, suppose all you're thinking about is, I bet the Earth has had some extraterrestrial visitations in the past. And now you're thinking, I wonder what that would predict. What should we see on Earth if this sort of thing happened? The answer might be you shouldn't see anything unusual at all. Or maybe you should see some unusual things. It's not clear that you should see unusual things, but you should expect there to be some traces of things that can't be explained by terrestrial beings alone interacting with the environment. But exactly what that should look like or that should be like is uncertain. So notice here that even if you should expect some traces of stuff that indicate the extraterrestriality of the beings involved, that is such a vague and generic prediction that it's hard to run around the world looking for an experiment to run to see. In any case, the predictions that von Däniken writes his book off of are all post hoc things that we already know about. So then you look and you see, well, it's not surprising. You already know that all of the things that he claims are predicted by the model have obtained. So it's already known information. So to call it a test is a little bit weird. We do get agreement between the post hoc items that von Däniken cites and the observations that we've already made, but that's not surprising since it's already known information that's present. And we don't know about the degree of fit with other explanations either. The important thing about this example are the lessons that we can draw from it. So first, there's no real prediction going on from the model that von Däniken generates. All we get are post hoc citations of stuff that we already knew about that such a theory could explain. you've got some stuff that you really don't understand how it could be done. Why are the Easter Island statues there? Why do the roads in Peru have the pattern that they do? How in the world did they do the pyramid construction? It looks like an engineering miracle to get all of that put together without heavy-duty machinery that we have now, but which they didn't have then. Okay, so you cite a bunch of stuff that you know obtained, and then you construct a theory precisely to explain those particular pieces of data. That's what a post hoc theory construction episode looks like. Now, sometimes known evidence confirms a model, but when it does, it requires more than agreement or fit. In particular, sometimes known data supports a theory, like the perihelion of Mercury, known throughout the 19th century and not understood in the 19th century, turns out to be confirming evidence for Einstein's relativity theory. But the difference is Einstein never developed his relativity theory to explain the perihelion of Mercury. He developed it on other grounds for other purposes, and then noticed as a side benefit that we get an explanation of the perihelion of Mercury from it. So when your theory construction is designed at a particular target alone, and then it turns out to fit the data that you know to be true, that's not terribly surprising. You'd be a really crappy theoretician if you're developing a theory to explain some data and then it turns out to be incompatible with the data. You're just not very good at theory construction if that's what happens. So sometimes known evidence does confirm a model, but there have to be some very unusual requirements that are met beyond mere agreement or fit. Mere agreement or fit is not good enough to generate substantial confirmation for a model. Now, what exactly is needed is very hard to say. But the mere fact that a model explains the data it was designed to explain doesn't count in favor of a claim that the data provide evidence for the model, or perhaps weaker, that the data provide much more than minimal evidence. To see why, just try estimating the probability of a model given the data and compare it with the probability of the model independent of the data. So let me write what I'm saying here. Here's the guiding principle. If you want to know when E confirms H, where E is your evidence and H is your hypothesis, the first guiding probabilistic inequality that you're looking for is you want the probability of the hypothesis on the evidence to be strictly greater than the probability of the hypothesis completely independent of that evidence. So this is the fundamental guiding probabilistic inequality for confirmation. So then ask yourself, if you develop a model to predict the data, but the data is already known to be true, then the unconditional probability of the hypothesis already takes that evidence into account. Because what is the unconditional probability of H? How do we understand that? Well, the typical assumption is this: let K be all of your background knowledge. Then the unconditional probability of H can be understood as the conditional probability of H given all of your background knowledge. So if E is known evidence already, if E is stuff that you already know to be true, then E is included in K. Hence, the probability of the hypothesis given E will be the same as the probability of H given K, unless there's something very special going on here, because E is included in K. Now, what I just said assumes something else. When you have a conditional probability, that's to be identified with a conditional probability that conjoins the evidence you're citing with the background knowledge in question. So every probability judgment that you make of any sort implicitly contains a reference to K, your background knowledge. So we let K drop out. So instead of talking about the probability of H given E and K exceeding the probability of H given K, we just talk about the probability of H given E exceeding the probability of H. It just saves us having to write out the more complex formula all the time. Now, given that, it should be a very rare and an unusual thing when you come to the conclusion that a model that explains data already known to be true is confirmed by that data. Something very unusual is going to have to be the case. So in the von Däniken case, you get a unifying explanation of a bunch of different features of the world, but that's already known data. The model was developed explicitly with the data in mind, and beyond that, the model doesn't really predict the data. It's not like you can look at the model, hey, there were extraterrestrial visits sometime in the past, and say, well, if they visited, here's what they would have done. They would have designed roads in Peru, they would have built pyramids, they would have constructed Easter Island statues. None of those claims are even remotely plausible. So it turns out the model doesn't predict the data. Instead, you get something weaker, like, well, the model is compatible with the data, but compatibility with the data isn't the sign of a model that predicts the data. So lots of reasons to be dissatisfied with the von Däniken chariot of the gods explanation. Another one, but a more astonishing case than the chariot of the gods case, is the reincarnation example that Geary talks about. So the example has to do with Bridey Murphy, the search for Bridey Murphy. And notice, this book apparently was not as successful as von Däniken's. But if you can sell 1 million copies of a book, that'll probably get you a good piece of change as well. So reincarnation has to do with this woman, Ruth Simmons. We don't know what the alternative model is, but the model for what we're trying to understand here is the reincarnation one. So we're going to find elements of fit between the part of the world, the real truth about Ruth Simmons, and the model that has us understand her in terms of being a reincarnation of one sort or another, or reincarnation of Bridey Murphy in particular. Once again, though, we're supposed to do calculations. We can't do it over here because we don't have an alternative model. But again, when you're calculating something, you have to be able to generate a prediction and not merely come up with something that's compatible with the model. So you do some calculations, and presumably the calculations are going to be this. If you are some prior person reincarnated, there's supposed to be a therapeutic technique, regression therapy, that will generate certain memories. They're hard to get at, but they're supposed to be recoverable in some sense. So you do that with Ruth Simmons, and you generate some hypnosis data. That's how you do the regression therapy. Then you look around to see if there actually was somebody like this, and you find something, you find a kind of agreement between the prediction of the theory and the data that you generate. Of course, you can't claim the same. You have no idea what to say on this side for a contrastive element, for a contrastive model, because we don't have a model. So what's the right thing to think about this? Well, first, we don't know very much about the research subject. If you really want to investigate this, you've got to learn a whole bunch more about this. As I understand the history here, once people learned more about Ruth Simmons, the reincarnation inference was debunked by further investigation of this woman. But in any case, in the absence of more information about the research subject, we can't determine whether the agreement between the model and the data is likely. And remember, that was, I think, step 6 in the original Geary program. When you get agreement, you have to ask, was the agreement likely? And one of the hallmarks of marginal science is you don't have any way to answer that question. Should the agreement have been expected? Such a lack leaves us with a bevy of possible alternative models which would also predict the data and what was needed for the attempt to defend reincarnation, to address these alternatives and provide other evidence against them. Without such additional evidence, we should conclude that the prior probability of the hypothesis is very close to the posterior probability on the hypnotic evidence. So you don't get serious confirmation for the reincarnation hypothesis from the data that you gathered. The last one is ESP. So ESP falls into 4 categories. There's clairvoyance, telepathy, psychokinesis, and precognition. Now, this makes it sound like ESP actually occurs. These are theoretical claims that if there is such a thing as ESP, these are the 4 kinds of possibilities that there are. And the site that I took this from says, those damn scientists keep ignoring us. Why? Because the experiments are unstable, thus because they're not repeatable. So you might get, this is going to be an important lesson. If you keep running repeated trials looking for ESP, just imagine taking an ordinary deck of cards and you're going to test whether you have extrasensory perception so that you can predict at a rate higher than chance what the next card is going to be that is dealt to you. So you make a prediction, and then we deal a card and see if you're right. And let's say we do that, let's do it 10,000 times. I think you're going to be bored with this experiment pretty quickly. But suppose you have unlimited patience to put up with this investigation. So we do it 10,000 times, and we get a result. The result is not likely to be exactly at the chance level. So your accuracy rate isn't going to be exactly 1/52, but maybe it's pretty close to it. We come back tomorrow and say, okay, we ran the test yesterday, let's do it again. Now, if you keep doing that, you should expect some outlier results at some point. Do it every day for a year, and you should expect some cases where your success was enormously better than chance, somewhere it's enormously lower than chance. You can't be that much lower than chance because the chance one here is just 1/52, so it's pretty low. But if you wanted to switch to where it was reasonable. You could just predict whether a red card or a black card was going to be shown next. And then you'll get some outliers both above and below the 50% mark. But if ESP is occurring, you should expect repeatability to the experiments. So the ESP example, you get this premonition, the Jack and Jill premonition case. And I don't know if you have premonitions. My premonitions are all bad, like somebody dies or my wife's leaving me or whatever. These are premonitions. But for the Jack and Jill case, maybe the alternative model is it's just a coincidence that this premonition was had. The other alternative is the ESP clairvoyance prediction. So do we get fit? Well, coincidence, if something is a mere coincidence, it's compatible with absolutely every piece of data collection you might come up with. Does that mean it fits the evidence? It fits the real world? Well, it's compatible with it. Whether there's fit is not clear. In the case of the clairvoyance explanation, we do get fit because if clairvoyance is present, we have a pretty specific characterization of what the premonition is concerning the accident, and then the accident did happen. I don't think the premonition was precise enough to locate the accident at the place that it occurred, but an accident occurred. So that fits the premonition case. You get the premonition. There's agreement between the model and the data, between the prediction of the model and the prediction of the data. I'm saying prediction, even though prediction, there's not a lot of calculation to what the clairvoyance model should generate. It's just some premonition or other is going to occur, so we get the one that actually occurred, and then it turns out there's an agreement between what really happened and the premonition in question. The lesson of examples like this, though, are these. Any specific mere coincidence is highly unlikely in itself. So you get this fearful premonition at one time, followed by the actualization of it in terms of something really similar to what was feared at a later time. If that's a coincidence, the probability of this, given the premonition, is very low. That's the way coincidences work. If it's an expected association, then it's not a mere coincidence. Okay, so coincidences are highly unlikely, but here's the crucial thing. It's also highly likely that unexpected coincidences will be observed. In the course of your life, there are going to be unexpected coincidences. No matter how much you know, no matter how much experience you have with the world, you'll get surprised by coincidences. That's because there's an important statistical lesson here. There will always be, it's always highly probable that you're going to observe outlier events. Nearly certain that there will be observed outlier events. So if you flip a coin, a fair coin, 100 times, that's your experiment. And you do that every day for 50 years. Here's an outlier event, 99 heads, 1 tail. Now, we know what the probability of that is. Well, we can calculate it anyway. I don't know what the actual number is. But it's extremely unlikely that if you flip it 100 times, you'll get 99 heads and 1 tail. But if you flip it 100 times every day for 50 years, the probability of this goes way up. So that would be an outlier event. It's completely unexpected, but outlier events are nearly certain to occur. on enough repeated trials. So if you're going to use unexpected coincidences as evidence for ESP, you better have more than a single case to go on. The evidence has to be gathered differently. It has to be tested differently. So a premonition where, oh gosh, I had a premonition and it was realized, I guess I have a very special ability to predict the future. Nothing like that should be persuasive to you. So the important thing are the lessons here. And here I'm gonna resist Geary's explanation a little bit. Here's Geary's position in the textbook. Geary's position is that the burden of proof is on the people who think this sort of crap is worth taking seriously. Okay, I'm overstating what his position is. But he actually does think this is crap. This is crap science. In any case, he wants to explain what our attitude should be in terms of the language of a burden of proof. I don't think that's the right way to think about it. So epistemology is one of the things that I work on the most. It has to do, it's usually thought of in terms of the theory of knowledge, but it at least includes the theory of knowledge. And this talk about a burden of proof is a common mistake in epistemology. Here's why. Burdens of proof belong to the law and other domains that have explicit rules about who has to provide evidence at a given point in a given exchange of information. So the thing about our legal system is if you're accused of a crime, you don't have to do anything. There is no burden on you to provide evidence that you're innocent. The burden of proof is on the prosecution. There are explicit institutional rules that tell us who has to do the work at any given stage in the inquiry. So that's the home for this language about burdens of proof. Outside such contexts, though, information from any source, testimonial or sensory or whatever, is subject to the same standards. What goes wrong in the cases we look at is not a failure to discharge a burden of proof, but instead simply a failure to provide evidence or adequate evidence to believe what is being claimed. So the idea here is it's not that these wackos had a burden of proof on them that they didn't discharge. It's just that everybody, wackos and non-wackos alike, are subject to the same evidential requirements as everybody else. So suppose just take a case where some people like to talk about burdens of proof that's different than the scientific case. So some people say, look, if you think there's a God, the burden of proof is on you to provide evidence for that. That strikes me as a mistake, and here's why. Burdens of proof apply in very specific rule-governed practices like courtroom situations. So outside of that, if you think P is true, it's your job to defend it. If you think P is false, you have a responsibility to provide evidence for it. So if you think there is a God, you can say, well, I think there's a God, I just don't have any good reason to think that. That's an option, but most people say there is a God, and then you have a responsibility to say why. Why do you think there's a God? And suppose you don't think there's a God. Equally, you have a responsibility to defend that stance. Everybody is under the same evidential obligations as everybody else. So it's not as if you're a Freudian, you have a burden of proof that us wiser, more responsible people about human development aren't subject to. Everybody's subject to the need to provide evidence. So I think Geary's analysis of the situation is not the right one. It's not the burden of proof that they failed to discharge. It's just that they didn't provide adequate evidence. And they're not subject, it's not as if these people are subject to a demand for evidence that those of us who reject their theories aren't subject to. What we have to argue for is their efforts failed because they didn't provide evidence or good enough evidence to believe what is being claimed. And this claim is one that we have to defend if we're going to be responsible inquirers. So talk about burdens of evidence is not right. You just have to look at the cases. You have to see, does it look like they provided adequate evidence? If you think it doesn't look like they provided adequate evidence, you have to explain that. And that's what we're doing by talking about vague and imprecise predictions and how alternative models generate just as much agreement with the known data as the model trying to be defended and the like. That's what you do when you look at the particular cases and try to explain why the evidence cited is not adequate evidence to draw the conclusion that is trying to be drawn.